So hi everyone, welcome. This is an amazing session, right? iOS, Android, C#, and Visual Studio. Who would have ever thought about it, right? Apple, Microsoft, Google coming together. So this is really interesting. How many of you know about Xamarin? Heard about it? Okay. Fantastic. So how many of you are mobile developers? Rest of all, are you .NET developers? Okay, fantastic. A few more surveys, like how many of you have an iPhone? Raise your hands here, come on. Or make some noise. Okay, how about an Android phone? Fantastic. And how about a Windows phone? How about other three? No? Okay, great. So this is pretty much the market that you have it in front of you, right? So you have varied market, iOS, Android, Windows Phone, and there is Windows 8 that is mobile platform for tablets coming up. So quite interesting. So, and how many of you are C# developers? Almost all of you. VB.NET? Great. F#? Nobody on F#? Okay, fantastic. So how many of you like this t-shirt? C#? Do you want one? So all of you who is attending my session today is getting free C# t-shirt. And I'll tell you how to get this. It's not a giveaway. It's going to be shipped directly from San Francisco. So you'll be getting this t-shirt directly from San Francisco. So I'll tell you, there is a simple app that you need to build. Are you okay? Are you okay? Oh, don't worry. The app is already built. All that you need to do is you have to download and hit F5, and then the t-shirt comes to you. Is that okay? That sounds better, right? All right, so we look at, so I'm going to demo that today, how to get your C# t-shirt. So here's what happened. I was at Kuala Lumpur airport a few weeks ago, and this was a week before MS-370 went missing, right? So I was there a week ago, and I landed, so I was not in the MS-370. Really? Well, that's a sad story anyways. So I landed at the Kuala Lumpur airport. The customs guys caught me. And I was going for a Microsoft event there. And these guys said, okay, scan your bag. I said, okay, fine. And I gave my bag for the scanning. And then he said, okay, open your bag now. And he was very strict. So I said, okay, I don't know what's in there. So I pulled out my bag. I pulled out the, what happened is I was carrying some leaflets of Xamarin, which said C#, iOS and Android apps using C# and Visual Studio. So I was carrying about 200 or 500 of them, I think two bunches of 200 each, and he was like, it's too much. So he opened up and he started reading this, and he looked at me and said, really? I said, what do you mean? I said, can you really develop iOS and Android apps in C#? I said, what? You're a customs officer, how the hell are you supposed to know this? And he was super impressed. He said, like, I was a VC++ developer, and I always wanted to move to C#. And my parents had this compulsion that I become have a government job and take care of this family and all this blah blah stuff. And then we sat together for next 30 minutes at the customs office. I was all alone, okay, in the room, and we were discussing C#, iOS, and Android. Can you believe that? So this is amazing. So these three things, these three words can get you into wonderful, sometimes troubles, sometimes really nice things. All right, so the point I want to make here is everybody of you who are a C# developer is a mobile developer too. Okay? So today, if you don't get anything in the session, it doesn't matter. All that you need to realize is if you're a C# developer, you can program for mobile. That's all I want you to take from the session. Okay? So, and this is exactly the reason why this particular session is not being scheduled for a mobile day. It's for the .NET day. And the reason for that is because you're .NET developers, and .NET developers, I mean, you have to be either on mobile or cloud, right? That's where the industry is going. Are you still working on WinForms, anybody? Yeah? When are you planning to quit the job? Seriously? Right? So anyways, jokes apart, I know a lot of them work on WinForms, but that's where the industry is leading to. Either you have to build a mobile app or cloud, or you have to be somewhere there, and that's the fast-moving thing. So what's driving mobile, basically? I'm not sure you guys can see this. There's no way I can zoom this in, but I'll just tell it out loud. So what's happening here is 32% of the people who are using the mobile. When I say mobile, it could be any form of mobile. Okay, it could be the tablet space. It could be anything mobile, which is technology oriented. So that's mobile. So around 32% of the people are spending time on gaming, and rest of us, 17%, some of us, are wasting time on Facebook. Okay, and a few of us are wasting time on Twitter, and obviously WhatsApp. How many of you are on WhatsApp? Yay! Where the $17 billion is going from you? Exactly. So that's what. So if you really look at, about 86% are the apps which are inside the phone or the mobile platform, be it tablet, be it any form factor for that matter. It's 86% is basically apps. The rest of the 14% is actually the browser. So if you really look at this way, even though you're building web, you're building mobile web, but still the take is it's fairly low as of now. So apps, if you're building for mobile, it has to be apps. It has to be native apps as well. So we'll talk about that. So unlike desktop applications, which are mouse and keyboard oriented, right? You have a pointing device. Your users, whatever app you throw at them, they're going to sit at one place and use them, right? But that's not the same case when it comes to mobile. People expect great experiences. They are either waiting for their boyfriend or a girlfriend in a coffee day, right? Looking at the apps. That's what we do, right? Nobody has a boyfriend or a girlfriend? I mean, the other way out. So anyway, so so your people, your users basically are expecting great experience from your app, which means your app has to be built natively. So this is an example of a Facebook. How many of you use Facebook on your phone? On your phone? On your phone. Yeah, so initially when Facebook launched, they launched a HTML app, okay? And that miserably failed. And you can see the ratings out here. It's about 1 star, it's about 923 people went ahead and rated it. And when do you rate? How many of you have rated an app in your phone? Really? Very few of us. Very few of us, right? Not everybody. It tells you, okay, do you want to rate this? Say, no, I don't have time for all these things, right? But someone who rates it, they're really serious users. If you're really irritated with the app, that's when you go and say, okay, I give them a low star. That's what happens. So that's what happened to Facebook when they started with HTML. But then they realized HTML was too early, and they betted big on that, and they changed to native. And look at what happens. And these are real stories, okay? These are real graphs. So there were 5 stars when they went native. So when they went native, what happened is they started making use of the entire features out there, which each platform provides. And if you look at the apps in each of the space, it's really amazing. The way, isn't it intuitive? Right? You're stuck with the Facebook app forever, right? Yes or no? Are you sleeping? No? Are you Facebooking? Are you WhatsApping? So apps have to be built native. So when I say apps have to be built native, they have to give you native performance. It has to give you some native, amazing user look and feel. So you can see some of the apps that are built completely natively, which gives you some amazing experiences. So look at this user experience and data visualization, the way it is, picks up. These are real apps which are in the App Store. Audio, this is an app founded by the Skype founders, and you can see how it looks on Android. It's completely Android specific. When you look at iOS, it's iOS specific. Look at this game Bastion. If anybody has played Bastion, no? So it's an XNA port. It was an Xbox game. They ported to iOS and Android as well. So there's a nice app called Calca. There's Toggle. Really nice app. So if you look at these apps, they make use of the native performances. They make use of the native features, right? So look at this. This is an iOS flight simulator, which is really cool. iCircuit, award-winning app in App Store. Now, the good thing about these apps are they're all built, whatever you saw right now, they're all built in C#, right? They're all completely built in C#, not the native that you see. So let's look at how, if you are a mobile developer, let's see what the approaches that are out there for you. So the first one is the siloed approach. If you guys know, if you have to build iOS application, you have to have Xcode, okay, as your tool set, and you will use Objective-C to build native apps. And similarly, if you look at Android, you have Java there as a language, and you will use Eclipse. And what happens to the Microsoft world, Windows? What do you use? Visual Studio. And then what language? C#, VB.NET, whatever, right? So, so you have this very different tool sets. Now, what's the biggest problem as a mobile developer? So you are a C# developer. If I ask you to come and say, okay, let's let's change your path, career path. Forget C#. Let's go to Objective-C. How many of you are ready for it? You're ready for it, sir? Great, that's awesome. Have you tried Objective-C? Have you? Okay. I give it to you. Anyways. So, how many of you moved to Java? Java? How many of you know lambdas? Lambdas. C# lambdas. Do you know when Java got lambdas? A few months back. About a month, I think. Right? So somebody tweeted, the topmost Google search was what is lambda? Because, I mean, C# users have been using from ages, but Java guys never knew what lambdas are. But anyways, so the point is not to compare Java and C#, but as a developer, you have 3 varied platforms, and it is impossible for you to, pick up another platform and write apps there, right? So what happens? You spin up a new development team. If you're an organization, you spin up a new development team. You have one iOS development team, you have one Android development team, you have Windows Phone development team. Now, what's the biggest problem? Let's look at it this way. So you want to add a new feature to your app. You can add easily on iOS. Now you have to do the same thing on Android. You have to do the same thing on Windows Phone. Now that's going to become clumsy, right? And the scalability of your code, right? You're going to maintain multiple codes, and that's going to be really, really tough. So this is the best approach if you can afford. If you're somebody like Facebook, you have $1 billion in your account, which you can keep buying people. So then you can go for this kind of approach. What's the other approach? This is the reason why this things the siloed approach exists. I mean the siloed approach exists, and the reason why the write once run anywhere approach exists is because of this siloed principles. So what's a right? Does anybody know what's a write once run anywhere approach? No? Nobody knows? What's that language? PhoneGap is, yeah, exactly. Sencha, PhoneGap, right? So what happens is you put a HTML, you put a JavaScript, you put a CSS, you put in some kind of a magic box, and that magic box is going to give you an app. It's going to give you a PhoneGap. It's going to give, if it's a PhoneGap as a magic box, it's going to give an app for iOS, it's going to give an app for Android, it's going to give an app for Windows Phone. So what exactly happens behind the scenes? So what it does internally is it puts a web browser in front of the user, okay? It puts 100% height, 100% width. And your HTML and CSS and JavaScript is going to render on that browser, okay? And your CSS is pretty much what it detects, what kind of browser you are in, right? If it's Apple Safari, for example, in iOS, then you put a CSS theme which looks like iOS, okay? You put an Android theme which looks like Android. You put a Windows Phone theme which looks like Windows Phone, right? So that's the write once run anywhere approach. So you're not writing different apps. You're writing a single app. Basically, your CSS and JavaScript is going to decide how it is going to look on each platform. What's the biggest problem with this approach? You get the lowest common denominator because you don't have access to the entire API that's available in iOS and Android, right? You're just on HTML and JavaScript. And in case you want to access that, what would you do? You would have to write an Objective-C core in case of iOS and expose them in JavaScript so that you can access those sensors. There's again a big problem of maintaining that source code as well, right? So write once run anywhere is problematic. So we don't suggest to use that. So this is where a unique cross-platform approach comes into picture, and that's Xamarin's approach. Here, it's a cross-platform solution, but it is not write once run anywhere. If anybody says Xamarin is write once run anywhere, throw it up. It is not. Okay, you don't write once and run everywhere. It is impossible as well. By the way, if you know the write once run anywhere solution, how many of you know browser fragmentation? So how many of you have written a HTML, JavaScript, and then did F5 and it run happily in every browser? How many of you have gone and fixed your code every other browser available? Right? What do? You go and Google the problem. You'll find, oh yeah, there is a vanilla JavaScript or a strawberry JavaScript or an orange JavaScript, right, to fix your problem. And you just go bring it, put it into your app, run it, oh yeah, it's all working. But then you break something else. And you do this recursively, right? All this is very good until you get into a point where you want to test all these things, right? It's a major mess. So the same mess is going to exist when you go with write once run anywhere approach, okay? So when it comes to Xamarin, it is not that way. It is like you build everything natively, Okay, so do you know what is the language used for the UI in Windows Phone or Windows 8? XAML, right? Do you know what happens in Android? What's the language for the UI? Do you know? No? It's XML. And what is it in iOS? Do you know? It's Storyboard, or it's the XIB files. Okay? When it comes to, so what happens is, an iOS developer, this is how he programs. He puts a storyboard and he wires up the code in Objective-C. In case of Android, he puts an XML and he wires up the code in Java. And in case of a Windows Phone, you know that you put a XAML and you wire up the code in C#. Your view models are in C#, right? Now, in case of Xamarin, you do the exact same thing. You will have XRB files in iOS, you will have XML files in Android, but you will wire those codes up in C#, not in Objective-C or Java. Getting it? So you're using the native UI. It's not only just the UI, but also some of the platform features, like if you want to use something really nice iOS 7 feature, iBeacons, right? It's an API that's available in in iOS, and it's now available in Android as well. So you want to make use of that, right? You have the API exposed to you in C#. That's what we do. So what we did is we picked up the whole API, iOS, Android, and we projected them completely in C# as is. So you get everything of C#, plus you get the 100% of API for Android and iOS. Got it? No? So you get native UI, you get native performance, and the other good thing is, now we call it as cross-platform solution, right? So how is it cross-platform solution? Because you write code in one language, that's C#. So it's pretty much easy to share the code that is not dependent on the platform. The codes that is not dependent on the platform can be easily shared between 3 platforms. How many of you use Instagram? Instagram? Use? No? It's a simple app. I mean, if you have heard about WhatsApp, Facebook buying WhatsApp for 17 billion, right? There was another app which was bought for 1 billion before, and that's Instagram. What Instagram does is it just takes a photo, adds some filters to it, and it uploads to the server, and people can like it. Same thing. So it's a photo sharing tool. Now what happened with that is, let's assume that you want to do something similar to that, right? Now what would you do? You will use Objective-C, you will build it on iOS, you will do the same thing in Java, and you will do it in Windows Phone. But imagine this way: you take the capture the photo, right? Capture the photo. Once the photo is up with you, it's a JPEG file. You can add filters to it. It's all simple algorithms, right? Think about those algorithms being shared in all the 3 platforms. So that doesn't have to repeat in case of Xamarin. But in case of native, it has to repeat because you have to write separate algorithm in Objective-C, you have to write separate algorithm in Java, and you have to write separate algorithm in Windows. That's not going to happen here, right? It could be any shared code, like for example, it could be cloud connecting. You're connecting to Azure Mobile Services, or you're connecting to Parse, any kind of cloud connecting, any kind of server-based connecting. All this code doesn't have to repeat in 3 platforms. You can easily share. So up to 70% of the code can be shared across. So if you guys know, this is how the Windows API looks like. So you have the system, system.net, system.io. Do you know all these libraries? System.link, system.xml. The base class libraries, right? Yeah? So you have these base class libraries, and then if you want to program Windows, you have other APIs like Windows Microsoft Phone, you have Windows Networking, you have Windows Storage, and all these kind of APIs. This is what it is, right? Correct? Yes? So this is exactly what's going to happen with you on iOS as well. So you will have everything of system.net, system.io, and all those things. Plus, you will have the other APIs exposed to you in C#. So for example, in iOS, you have a map kit, which is for using maps. You have UI kit. All the UI controls that you see there is built on UI kit. And you have iBeacon, core graphics. So all these APIs is basically exposed to you in C#. And the same thing applies for Android as well. Got it? So what it means is you get 100% API coverage, no matter what. If you're already sleeping, I don't mind. I want you to wake up and read this for me, and then you can go back to sleep. Right? So anything you can do in Objective-C or Java can be done in C#. 100%. That's guaranteed. Okay? So how does this whole thing work? So how many of you know p-invoking? Heard of it? Projections, if you know, in other languages. How you project your base something like C and C++ to the higher level language. It's a similar technology. We call it as bindings. So we expose this whole Objective-C APIs or Java APIs in C# for you with a technology called bindings. So you get as is, okay? Which, okay, so that's what happens. And the other thing that I want you to tell me is, how does .NET work? You have a code, it can compile to IL, right? And what happens to IL after that? Just-in-time comes into picture and compiles it further, right? Now there's a big problem in iOS. iOS has a legal and technical restriction, says you can't compile the code at runtime, okay? Which means JIT is not possible. No just-in-time. So what we did is we used AOT. It's called ahead-of-time compilation. Whatever JIT does during the runtime, we pulled it to the compile time. So it becomes ahead-of-time compilation. Now, it comes with a small drawback, like dynamic is not going to work. Reflection.emit is not going to work. Okay, there are a few things that will not work, which is kind of highly dependent on the runtime. So, and remember, that is only applicable in case of iOS. In Android, it is an open source world, right? So what we did is we built Mono directly there. So you have a runtime, .NET runtime, running there in Android. But it's the only difference between iOS and Android is, in case of an iOS, it compiles down to ones and zeros. So if somebody says, okay, here's Objective-C code, and here's a C# code, and if you try to reverse engineer, you cannot get to know it was built with what. Was it built by C# or was it built by Objective-C? So it's going to be as is. The performance is going to be as is. When it comes to Android, you will have the APK files, but the thing is, you will also have the Mono runtime. Do you know that Java runs on Dalvik? Have you heard of it? Dalvik VM? Yeah. So this is how Java runs on Android, right? You have a Dalvik VM which is running the Java. Now, similarly, here the Mono is going to stay parallel to Dalvik. It is not running on Dalvik. Instead, it's going to stay parallel to Dalvik. So most of your C# code is going to perform much faster than Java itself, right? So can we say hello to iOS now? You want to see how to do an iOS application? Yeah? Okay, so let's start. So this is Xamarin Studio. You can do the development completely in Visual Studio or in Xamarin Studio. Xamarin Studio is a free IDE. So if you're developing on Mac, Visual Studio is not going to work on Mac, so you'll have to use Xamarin Studio. So what I do is take a file new solution, and here you can see that there's iOS, iPad, iPad Storyboard, and all those things. So do you see that? Yeah? Okay. Cool. So select an iOS application. So for now, I'll take an iPhone Storyboard. Let's say a single view application. Let me choose a proper path. Okay. So call this as image share, right? Click OK. Now what you see is it's all C# on the right side of it. Do you see those using system and all those things? Yeah? Yes or no? Okay. On the left side, do you see the Solution Explorer? Very similar to Visual Studio, right? So now here's something that you never see it if you're a C# developer. That's the Storyboard. Now Storyboard is how you design your UI in iOS, okay? I'm going to double click this and see what happens. What's this? Do you know? It's an Xcode, right? Xcode is, if you didn't know, Xcode is the IDE that's used for designing iOS applications, writing, basically developing an application. So what I'm going to do is I'm going to design the Storyboard. So what we're going to do is we're going to do a couple of things. Let's put two buttons out here first. So I'll search for a button. So drag and drop this button out here. So basically what I want to do is I want to have two buttons. One is take a picture, and then another button, share a picture. Okay, and I'm going to add another image view in between. So I want to take a photo, okay, load it to the image, and then finally share it to Twitter. This is a simple app, right? So let's build that. So I'll call this as take a picture. So drag a little down so that you can see. And I will add another button, which is called share. Now, once I take this picture, I want to show it to the user that I have to capture this photo. How do I do that is I add an image view to this whole thing. So I'll just drag this image. Right, so here's the image view. Okay, so now I design the UI. This is not the way you design your iOS UI, but this is pretty much what you can do on a demo. So what I'm going to do is something which is so unusual for you, that is building outlets. So so this is how it works. So if you have worked with XAML, if you want to access the object in C#, what you do is you provide a name to it, right? And then that name becomes a property. And then you say property.touch or property.click, you add event handlers and blah, blah stuff. Now here, in iOS specifically, you need outlets. So I'm going to drag an outlet. So this is how you do it. You hold a control and then drag it to this code. And then now I'm going to say that this is a take a picture button. Right? And I have my image view. So I need to have a hold of that as well. So so I just call it as picture view. Right? And similarly, I need to have a handle of button as well. So you don't have to do this. If you want to completely build in C#, you can do that. Okay, it's totally allowed. But I want to show you how we are making use of the native UI and how we can integrate it together. Right? So that's Xcode. I close Xcode once I design that. That's pretty much what I wanted. Now, the next thing, Xamarin Studio actually goes and does the synchronization part pretty much automatically. But if it doesn't do it, okay, it's already done it. So it says synchronizing changes from Xcode. Once it is done, you can pretty much go on your partial class and see if these objects are available for you. So it says picture view, share button, take a picture, right? These things are available for you. So now you don't have to really worry about all these methods. So we can go into the details maybe later, but let's make this app work. So what you need is there is a method called viewDidLoad method. This is the first method that gets fired in iOS. So as I told you, it's exactly how an iOS programmer programs in Objective-C, but that's in C#, right? So here, in the viewDidLoad method, I have the accessibility of those objects because that's a partial class, right? So let's say if I want to capture the take a picture button. So what I want to do is, in iOS, there is no click button, okay? There's no click event. It's touch up inside. So you need to make sure that you add that. Can you all see the code? Yes? Okay. So we're going to use async await. What feature is that? Is it a C# 5.0 feature? Right? Why do we use async await? Asynchronous programming? Do you think that's the right thing to do for a mobile development? You don't want to hold your user on a main thread, right? So you have to go to a parallel thread and then do your task and come back to the main thread, correct? So I'm not going into the details of explaining you what async await is, but anyways, so that's what we do. You can use a normal event if you wish to. But I'm using an async and await. Now, I have a take a picture button, so when I click on the picture, I want to capture the image, right? It could be from the photo, it could be from the camera, or it could be from the library. So since I'm going to run this on a simulator, I'm going to use a library, photo library, because you don't have camera access in iOS simulator. Okay, so what I want is, I want a picture controller. So what I do is, I'd say picker and new image picker controller. So this is the class that gives you the view of picking that photo from your photo library. So I have the picker here. Now, let's do one thing. Just so what we do is, I'm just going to present this view controller, right? So take the picker and I say present this to the user. So when this button is clicked, this view controller comes in and says you can choose your photo. Okay? Do you want to see what happens? Let's run this. So here's the iOS simulator. So this is the simulator that gets shipped along with the iPhone Xcode. So you click on take a picture. You saw that? Do you see Pinal Davi's photo there? Right? So you get this picture control there. Now I try to cancel it for now. So what I do next is I need to capture this photo and put that into the image view, right? So let's do that. So I need to get a handle of the image view. So what what I need to do is when I say picker.media, finish picking media complete, I basically want to do some task. So I use a task handler here. Again, we want to be nice, so we say async out there. The next thing is once I capture the media, I want that image from the from that thing, right, from the picker, and I want to assign it to the image view. So to do that, what I do is I need an UI image, so I'm just going to write this here. So I just say UI image. Now this is the image that I'm going to set it to. What's the name we gave? Is it picture view? Yeah, that's picture view. So picture view dot image is what I want to give here. So image, basically this image is available to you from this event, right? Can you see that? So that's the event. So it comes up there. So let's see if that works well. Okay, we have a bug. So I click on this, see nothing happens. And the reason why nothing happens is because you did capture the image, but you didn't dismiss that view controller because that view controller is still existing in front of the user, right? So you didn't do that. I didn't do that. So I said dismiss view controller because again I'm on a sync, so I can use okay, so let's run this. Let's see if this image capture has happened or not. Take a picture, right? Got it? Yeah, it's pretty simple. Now, another thing that I can do is I can share this code on Twitter. Now, if I want to use on Twitter, what I need to do is I need to have the Twitter API. So I say monotouch.twitter. Now, anything that you see as monotouch is basically the Cocoa Touch implemented directly in C#. So whatever iOS gives you. So this Twitter API is basically baked into the iOS API. It's not nothing Xamarin has done there, okay? It is going to be the same thing what iOS people do. So now I have the Twitter API. So what is it? I need to do this on a share button, right? When I click on share, that's exactly when I want to share it. So we need to wire up the share. So let's go do that. So your share button is share button dot touch up inside. What do you use? Async? Yep. So you use a composite view controller. Again, this is the controller that comes up to give you the Twitter thing. So I say, okay, add an image to this, right? The image is basically the image that you captured and assigned it there, right? Got it? Now, this is not yet over because you just created the controller, but you didn't present this controller to the user. So you need to do that as well. So you say present view controller, async again. So here I say present Twitter and let's run this and see how easy it is to share Twitter on Twitter, the picture that you take. So I take a picture, right? I can say share. Saw that? The Twitter handle came up automatically, right? So so now this looks very lame, right? I mean, you just take the image, you capture the image from the camera, you upload it to the Twitter. Now let's do a little more work to this. What I want to do is I want to add filters to it. How many of you attended the Penal session? Penal Davis session? Did you attend the last one? Yeah, so he was telling about making him thinner, right? So we'll try something similar to that, but we can't make him thin though. It's difficult. So we can add some effects to the photo that we took. So for that, I need to use monotouch.coGraphics. Once I do that, basically what I want to do is as soon as I capture the image, I want to apply filter to that. So this is something very similar to the Instagram that we do. So let's add a vignette filter to it. So okay. Need to resolve this because I didn't add CI. So I add a CI vignette. Now I say my image is basically the image that I captured here. Oh, let's do this. We'll store a temporary variable and use that out here. Original image, that's the capture. So I put the same image. You don't have to worry about how this is done because everything is documented there. I always do that mistake. Okay, so you do that. So you did add a vignette effect. You assigned an image to it. The next thing that you need to do is you need to assign a radius. How much of radius that you want to provide to that vignette, right? That's one thing. And then you also want to say how much of intensity do you want to do for this particular thing. So you basically created an image. You added a vignette effect to that. And the next thing that you do is I also want to add a sepia tone to that, right? Do you know what's a sepia tone? Very brownish look for the image. Okay, so let's do that. Have you ever seen those photographs of Facebook profiles whom when you meet in real time they don't look like that, right? So that's exactly what we're doing here. So so I'm adding a sepia image, sepia tone basically. So CI, I keep forgetting it's sepia tone. Now, what is happening, what I'm trying to do here is I'm using the API of iOS to do this graphics for me. Okay? Now, this graphics is going to be rendered in the GPU, not in your CPU. Okay? It's not a software rendering. It's going to be on the GPU. So that's the reason why I'm taking this effort. But if it's a simple algorithm, you can definitely do it. But these are really complex algorithms, so you need to run it on GPU for better effects. So now what I do is I'm assigning a sepia effect to the image that was added a vignette effect to it already, right? So I say image from the vignette effect. So I say this. Got it? So I got the sepia. Now I get all these things fine, but the last thing I need to do is I need to assign this to a context. If I don't have a you don't have to, I know you're looking a little bit worried about all these things. These are all pretty much in the documentation, and it is how the iOS expects you to do, right? So you don't have to, the moment you start doing this, it's pretty simple. The good thing is I'm not doing it in Objective-C, right? I'm doing it in C#. Are you able to understand the C# at least? So why don't you say that? Right? Okay, so basically what I did is I captured the image, taken the image, and I added a vignette effect, and I added a sepia effect to it. That's all, right? Now, all these effects come into place when you add a context to it. So I'm going to create a context. So I just say CGI, CI context basically, dot create. Now, what was that? What was that? Keep forgetting that. It's from options. So yeah. So I add an options. And basically, I add it from the option because I want to make sure that they don't use a software rendering, but use the GPU rendering, so that I can make use of the platform features out here. So I get the context. Now, the next thing I'm going to do is I'm going to say context dot create CGI image. Basically, now is the time exactly whatever chain you created, right, from vignette to sepia. Now, when you call this create CGI image, that's when it chains back up and then adds effects to that on your GPU, not on your CPU. So it gives you better performance. So yeah, so now you have the image. So that's the sepia dot output image, and then it also asks for a rectangle. So I just say sepia dot output image dot extent. So basically, it gives you a modified image. All right. Now, all that I do is, okay, this is not going to work. So let's initialize a UI, because what it gives you is a CG image, I think. So you need to convert that to the image that your image view understands. That's it. Let's run this. take a picture, take the photo. Saw that effect? Do you see that? Yeah. Now let's share this. Oh, there's an exception. So, how do we find out what exception is that? How do you actually do this? Do you debug? No. So I said take a picture. Okay. So what has it? Has image. That's perfect. Now you have. Oh. Okay. Let's see. So that's the controller. Cool. Oh, that's strange. So it says add image. Somebody told me never do live coding on the stage. So take a picture. What? Not assigned? Oh yeah, you're right. We just assigned to this, right? Does that work? Does it work? No? Let's see. Oh, I'm not going to do it. Perfect. So we assign that image. So make sense? Does it look nice? Done. You can go to Twitter and retweet it if you want. Done. Great. So let's go back to the keynote. Okay, so what you saw right now is we said a hello to iOS in C#. What would be finding surprising for you is that you're doing everything, something not so usual that you've been doing, right? The good thing is you're doing in C#, but the best thing I would say is you're doing the iOS development in C#. You're making use of the platform's features. You're making use of the APIs, right? Imagine if you're an ASP.NET developer, if you have to go to Windows Phone, what would you do? You would do the same thing, right? You would look at the APIs to do how to do this. That's all. It's the same learning curve that you have right here as well. So how do you share code across platforms? So the way you did iOS, you can also create file new Android project, and this Android project is going to look exactly same as how a Java project should look like. Does that sound good? No? Yeah. So how do you share the code? So you saw that iOS UI was hand-coded exactly like how an iOS UI has to be coded. You can do the same thing when it comes to Android. So you have Android UI out there. Now the same thing is going to happen even in Mac and Windows. But the good thing is because you're writing in C#, you can have an enormous amount of code that can be shared in all the platforms, right? What are those kind of codes that can be shared? Cloud connecting, right? You're connecting. Now you took this picture, okay? You are storing it in your cloud. That cloud connecting part can be shared, right? And similarly, you can have your business logic, your data access. There's a lot of Humpty Dumpty things that you can actually share between all the platforms. So remember, it's native code without compromising on code sharing. So what are the ways, how do you do this code sharing? Does anybody know what's a file linking? No? So what do we do to wake you guys up? What's that? Okay, who said that? Who said that? Okay, come on. Come down. So here's a C# t-shirt. Yeah? So who else is asleep? He woke up. Okay, great. So I know it's difficult. It's especially difficult for the sessions after lunch. That's okay. So does anybody know file linking? The person who has taken the t-shirt, come on, where is he? Where are you? What's file linking? Do you know? No idea? Okay, so when you want to share the code, right, if you guys have ever worked in WPF Silverlight world, right, WPF and Silverlight have a very similar technology, right? And say, for example, if you have ever tried a third-party components, or if you have downloaded the open source part of those WPF Silverlight components, you would know that many of the files, the logic of those things have been shared across. Now, how do you share it? The sharing is by using a technology called file linking. So this was done those days, but things have changed. You can use still. So the file linking is all about, instead of adding a file, you add the file as a link, which means actual file exists somewhere else. You only link the file. Okay? So now think about it. You have Android, you have iOS, you have Windows Phone, you have Windows 8. Right? So you add the whole file as a link in all these projects. So that means you'll have original source at one place, but you have these files in each project. So the moment you compile, it takes the whole file from there, copies into your current project, and compiles it. So as a developer, that's how you can achieve code sharing. You're not necessarily, repeating the code. It's there at one place. And why do you need this? Why can't I take the library route? Why can't I use the .NET DLL? Right? It was supposed to be meant for that, right? Why do you think so? Another C# T-shirt for someone who says that. Dependency on what? Right? Yeah, why? Silverlight is a great example that you said. What the reason? Okay, I'll put it this way. The reason why, you don't have the entire .NET runtime in Silverlight, right? No? Was it? Yeah, plugin is required, but the plugin doesn't have the full .NET runtime. The DLL that you create is basically compiled to the whole .NET framework profile. Now that profile don't exist in case of Silverlight, right? So that's the reason why you take up some rules like file linking, so that when you compile, it compiles to the subset of the .NET framework, and it is part of that DLL. And you are not compromising on the code sharing. Got it? Got it? No? Yeah, I see some faces. Okay, cool. So in this case, what we're going to do is, if you have some files to be shared across, you create a core project, and you put all the files in the core project. And you take this project and link it to your actual iOS, Android, or Windows Phone, or Windows 8, or Silverlight, or ASP.NET, or whatever .NET projects you want to take it to, right? So you can have everything in one particular solution. So another example is, you can also use portable class libraries. Heard of portable class libraries? What? C# T-shirt. Yeah. But why do we need portable class libraries, like, as opposed to the .NET libraries that we already have? Okay. Yeah, exactly. But DLLs are, we answered that, right? DLLs are also reusable. Yep. What platforms? iOS, Android is Xamarin. PCL is Microsoft. No. So again, it goes back to the same thing what we discussed previously in the file linking. We need a subset of the .NET framework that it has to run on, right? Getting it? So Microsoft created a PCL, which is called Portable Class Libraries, which means when you put any code in PCL, that is compiling to a subset of the .NET. So what is the difference then between file linking and PCL? Who's confused? So nobody's confused. So now answer this. What is the difference between a PCL and a file linking? No? PCL is a DLL, exactly. So one is deployment time and one is compilation time, right? So PCL, once you compile it, it becomes a DLL, and that can be referenced everywhere. File linking is during compilation, the whole file gets copied into into your current project and then gets compiled. Getting it? And who uses PCL and who uses file linking? It's a $1 million question. So yeah, exactly. Who answered that? So you have a T-shirt. You can come down as soon as this one gets over. So when you're a third party, right? You don't want to ship your source code. So you compile it to a PCL. All the libraries that comes from NuGet now, if you really look at it, some of them have started to become PCL compliant, which means, and you also have to look at whether this PCL is going to be supported in Android and iOS. So how do you do that? So when you create a PCL, you basically get this, when you say file new portable class library, you get a small window which says which PCL do you, or which all the frameworks do you want to target to. So you check on all these things. So you say .NET Framework 4.5 and higher, Windows Store apps, Windows Phone 8, Xamarin Android, Xamarin iOS. And Xamarin Android and iOS comes up only if you have installed Xamarin. Okay? So this particular thing comes up, and then you can choose this. Internally, it creates a profile for it. Okay? Nobody knows what profiles are, it's except for some Microsoft folks that they know. There are some numbers generated, like profile 151, profile 76, right? 131, 136, I don't remember that. So there are profile selected. So when you select these things internally, there is a profile number gets selected, and it is targeted to that particular profile. So when you download a PCL, say if it's from NuGet, make sure it is supporting Android and iOS. Then you can take this portable class library and make it work on Android and iOS projects as well. Getting it? Okay, so have you heard of Universal Apps? Universal Apps. How many of you tried seeing the Build conference happen last month? Yeah. So they announced Universal Apps. You heard? So basically, it's an advanced form of file linking, I would say. What happens is instead of linking each and every file, you can actually take a project and reference it. So internally, it is basically taking all the shared file and compiling it into your particular source. Okay. So I'm running out of time, so I have one more interesting demo to show you. That's how to get your C# T-shirt, if you haven't got it here. Okay. Now here's what you need to do is you need to go to this website called xamarin.com/sharp-shirt. Okay. Let's see if I have internet. It's this. There you go. So once you go to this website, or you can come to my booth, we'll tell you how to do this. You have to install Xamarin. It could be, you can use a free starter version, which is like for if you're building small apps, it's totally free. You can use that, or you can use a 30-day trial version, which has full feature set. Download that and install it, and then use GitHub or download the zip. You get the entire Xamarin Store app, and then run this app. So let's run this app. I have this app. So if you see this, now you see a shared library out here, right? So you can see that data, helpers, models, all these things are basically shared between Android and iOS. So we'll look into that later because we're running out of time. So right now, let's just simply run this application. So this is as this, the moment I download it, what I get. So I'm running on iOS. You can run on Android if you're running on Windows machines, because iOS requires you to compile your code on Mac. That's a restriction from Apple. So you can develop on Visual Studio, but you still need Mac to complete the compilation. So it has to be on the network. So here you go. So you can choose if you're a man or women, depending on that. Select the T-shirt, add to the basket. So you go to the basket, say checkout, and now here you go. It tells you a small task is required to get your free T-shirt. Please add your Xamarin account email address to loginviewcontroller.cs, then revisit the screen. Okay, that's all you need to do. This is something we are validating if you're a proper C# developer or not. We want to validate before we give out C# T-shirts, right? So it says login view controller, and it tells me to add this. So you can see a Xamarin account email, right? All that you need to do is add that email there. So go register yourself. When you download it, you will have this registration, and just run this. So you run that. So I select, add to basket, checkout. See how it gives you a username and password. Just log in, provide your address, submit it. That's it. The T-shirt will come to your home, and do it before the stocks last. Okay, so one more thing, one more topic on my. This one was Visual Studio. So I just want to show you that all these things that I showed you is going to work on Visual Studio. So here you go. You will have Android and iOS projects. So if you're working on Visual Studio, all that you need to do is file new project, choose iPhone or iPad or Android, and say OK, and then start programming there. Make sure you have a shared project. So you can see all these things are basically the shared project that is shared between Android and iOS. So you can have Windows Phone, Windows 8, ASP.NET, entire project and solutions can be added to this. So I wanted to cover a few more things. But anyway, so I'll open this up for questions. So that's the URL that you need to visit. Do you have any questions? I have a few more T-shirts to be given away. Or should I ask you a question to know whether you are awake? Yeah. So when you install Xamarin, if it detects a Visual Studio, it gets an add-in to that. So that's, yeah, you can either use Xamarin Studio. Okay, that's like Visual Studio with lightweight features. So you have everything of Visual Studio, but with lightweight features. So that's like a free thing. Okay, so if you're already a Visual Studio developer, you can make use of Visual Studio itself. What is that? Packaging and deployment exactly same as how iOS and Android does. So Android, it has a .apk file that it will be shipping to. So this whole thing, when you say deploy and compile, right, it gives you an APK file. So that APK file you can submit to Play Store or wherever you want to. Yeah, I just still get I think one T-shirt is reserved, right? So you are asking, why shouldn't I build on HTML? Why should I go for Xamarin? Is that the question? Oh yeah. So see, now the biggest problem is if you're native, right? You can't share the code. So you can download this app to know what are the codes that has been shared. So for example, let's say model view controller pattern. Pretty much everything from model and controller can be shared across. Only the view has to be rewritten, right? So same pattern. So if you write an Objective-C or Android in Java, it gives you the same performance. It gives you everything of the native. But the bad thing is you can't share the code. If you want to add a particular feature, you have to go add it in every. So it's not. We are partners. We are big-time strategic partners. Microsoft does everything for Windows. We do it for everywhere else. Have you guys heard of Mono? So we are the team who built Mono. Okay? Huh? Licensing, I said you starter edition, if you want to use, it's a free. You have indie version, which is about $299, and there is about business edition, which is for enterprises and other things. What is the price for that? $9.99, I think. It's a subscription, exactly how MSN subscription works. It's a subscription model every year. Yeah, exactly. So, no. So, see, once your app is built, it is as good as a native app. So if they say iOS is allowed, the same iOS features are allowed for you in Xamarin as well. So Xamarin is not something, see what Xamarin has done is expose the API to you in C#. At the end of the day, it's going to be iOS and Android apps. Yeah. So there is a framework from Samsung which they wrote for Xamarin, which you can use for this extended security and other things. So there are a lot of third-party people who will write about it. What we do, we give us a platform. It's not a specific LOB thing. It's not a line of business solution that we're giving. We're giving a platform. So even if you have built it, you can build around that. Getting what I'm saying? So there is a Samsung security model. I don't recollect the name right now, but there is a security thing which you can use it. Great question. Oh, it's timeout. Yeah. When it comes to iOS, you get the same performance because we are compiling against Objective-C runtime itself. So you get the same performance. In case of Java, nobody's quoting me, right? C# performs faster than Java. Okay? You can quote me further. We have an entire blog to prove that, right? That's what I said. We have the entire blog to prove that. We have the performance optimistics. There is a interesting project called, if you're interested. No, I'm only talking about the Dalvik performance, not Java exactly. The Dalvik VM performances. So because we have mono runtime, which is 13-year-old. Yeah. Okay. So basically, see, the thing is, again, it depends on what you use. Okay, one of the everyone's called it as a disadvantage. What happens is, because this mono gets shipped along with your app, there is a small amount of size that goes up than your regular Java app or regular iOS app. That's the difference. Because you're making use of all the system.NET, system XML, system IO, right? We have done our best to use file linking to strip out the code that you don't use, but still, it will be little higher than a regular, project. Yeah, everything is managed code. Yeah. Yes, Xamarin will ship the garbage collectors. Yes. So let me just stop there and tell you this. Our garbage collector is as old as the .NET's garbage collector. Okay, it's 13-year-old. It's a mono garbage collector. So you have the same thing, same performances out there. Yeah. Hi. Somebody had to collect the T-shirt from me. Yeah. You can use in Xamarin. So if you have an Objective-C code, you have a Java code, you can bring it to Xamarin exactly using the same technology that we built the entire framework to you. That's called bindings. So you will have to use bindings and you can bring it to the C#. You can port line by line. Thank you, sir. So one more T-shirt. Who wants it? Oh yeah, that's a good question then. Yeah. Yeah. So others can get the C# T-shirt by compiling the code. Did you get your image?
You can gather at the stall and they have some exciting prizes to give away.